the following. Binomial expansion to start off with. Because we did Pascal's triangle, and we're learning something called the binomial theorem. So what's a binomial? A binomial is something with two terms, a plus b. And if you had different powers of binomials, for example, if I did this to the power of 1 and simplified it, this is really difficult, what would I get? To the power of 1, it would be a plus b. Not super tricky. What would you have to do if you had a plus b squared? You'd have to write it out and then FOIL it out, right? And you would get a squared plus 2ab plus b squared. And if I did this on a separate page first, a plus b cubed, which is a plus b times a plus b times a plus b, and I already knew that those ones were a squared plus 2ab plus b squared, and I just had to multiply by another a plus b. Then this a would get multiplied by each of those, and this b would get multiplied by each of those. And if you simplified it, you would get a cubed plus 3a squared b plus 3ab squared plus b cubed. If you wanted to do a plus b to the 4, it would be a plus b times a plus b times a plus b times a plus b. Would anybody like to try it in their head and just tell me the whole answer? Close. A squared, b squared, good.
And then plus 4ab cubed plus b cubed.
B to the 4. Now, I didn't put 1s in front of these, but I could have, right? And we didn't do a plus b to the 0, but that's just equal to 1. But when we're expanding binomials, we get Pascal's triangle. Now, part of the reason Pascal's triangle comes out in a binomial expansion, and I'll show it with a plus b to the 4. What ends up happening, and we'll use this as an example. When 4 things like this get multiplied together, what ends up happening to get an a cubed b is that an a has to get multiplied by another a, and that has to get multiplied by another a, and then that has to get multiplied by one of the b's. And that would give you an a cubed b. Now, we could get the a cubed b by using this a, this a, this a, and this b. But we could also get an a cubed b by using this a, this a, this a, and this b. And so we ask ourselves, how many ways could we get just one b? How many b's are there? 4. And how many ways could we choose one of them? 4, choose 1. If you wanted a plus b, a plus b, a plus b, a plus b, if you wanted the a squared, b squared, in order to get this, how many b's do we need? We need 2 from the 4. So that makes this 4, choose 2. And that's why that number appears there. And if we wanted all 4 b's, we have to choose all 4, and there's only one way to do that, and that only happens when it goes b times b times b times b. And the same thing here. You could either think of this as choosing all 4 a's, or choosing, to follow our pattern that we had before, choosing 0 b's. And so on your formula sheet, there is a formula for any term in a binomial expansion. It says, for a plus b to the n, you can find any term number, and it's written kind of strange. It's got a k plus 1 in there. And I'll show you why that is. But let's say I wanted to find this red one that's squared. In a plus b to the 4, does it make sense that there's 1, 2, 3, 4, 5 terms? And I would call this one my first term, the one in the red box is my second term, then the third term, then the fourth term, then the fifth term. The reason why the formula has a k plus 1 in it, because, wow, your coefficient, your number in front, which is the 4 in the red box, is 4, choose 1. The 4 comes from whatever the exponent is. If the exponent is 4, you have 4, choose 1, because there'd be 4 of those terms. And by doing term 2, if I'm wanting to find term 2, what does k have to be for that to equal 2? 1 less, it has to be 1. And we notice that in the second term, it's 4, choose 1. In the third term, it was 4, choose 2. We notice that this number here is always 1 less than its position in the row, right? This number here is 4, choose 3, and this 3, this is the fourth term, 1, 2, 3, 4. So whatever that choosing value is always 1 less than the term number. So in our formula, we have a tk plus 1 saying term number whatever, this here, this is always 1 less. If I wanted to find term 7 in something, then this would be a 6. Now, how many a's are there? When it was 4, choose 0, there was 4 of them. When it was 4, choose 1, there was 3 of them. Then 2, then 1, then 0. How do we use the position and the exponent to tell how many a's there's going to be? So see if that makes sense. If I was finding the first term, what would k be? K would be 0. And so does it make sense that there would be 4 minus 0 a's? If If I was finding the second term, the one in the red box, then k would be 1. And does it make sense that the number of a's there are 4 minus 1? In fact, we can see that if we just look, this is always n and this is always k. Can you see if you subtract these, you always get how many a's there are? And the number of a's keeps going down by 1. Whereas the number of b's keeps going up by 1. And the number of b's is always the same as this number here. Start with 0 b's, then 1, then 2, then 3, then 4. And this formula is on your formula sheet. You don't have to memorize it, but you do have to know what everything stands for and how it relates together. And what's really nice about this formula is a couple of things. You can find a term very quickly instead of having to multiply it all out. Some other general observations that we can have from this, and we'll do one term really quick to end up class, but for a plus b to the n, there are always n plus 1 terms. If I scroll up, a plus b squared, how many terms are there? 1, 2, 3. That's usually how I remember how many there are. I go back to the easy one, a plus b squared, and I say that one has 3 terms. Then the next one has 4 terms. The next one has 5 terms. So the number of terms is always 1 more than whatever the exponent is. And that is a very typical 1-mark question. How many terms are there in the expansion of 2x plus y to the 15? And you say, there would be 16 terms. Always 1 more than the expansion. So if we took an example and I'm going to change the letters just to get you used to changing the letters. X plus y to the 11. We want to find the 7th term. So, if we were finding term 7, what does that tell us that k is? First of all, according to the formula, we start with n choose k. N is always the exponent, so it'll be 11 choose what? Six. Because k is always 1 less than the term number. And then instead of a, what would be here? X. And you'd go 11 minus 6. And instead of b, we have a y, power of 6. So you go to your calculator, figure out what 11 choose 6 is. You would get an x to the 5 and a y to the 6. $462. And so without having to expand everything completely, we can find a term a lot faster. And that is the binomial theorem. So what we're going to do tomorrow in the afternoon is we are going to look at the different kinds of questions that get asked with the binomial theorem. But some important patterns that we've noticed. We notice Pascal's triangle appears in there, and that's what gave us the n choose k as the first part. We notice the powers of a went down by 1, and the powers of b went up by 1. And we also noticed that there will always be n plus 1 terms.